Hello everyone and welcome back to Study Room. In the previous few lectures, I taught you a new chapter of mathematics that was factorization of algebraic expressions. We learned a lot of new concepts there. So, in today's video, we'll be going through a quick recap of all the concepts that we grasped. So, let's get started. The very first thing that I taught you was that whenever we factorize a given algebraic expression, then we represent it as a product of its irreducible factors. Now, what do you mean by irreducible factors? Irreducible factors means we are representing it in such a form that these factors cannot be further represented as a product of its factors. For example, if we have an expression like 5xy, I can see that 5xy is in the factorized form. Why? Because it can be represented as a product of its irreducible factor, that is 5 multiplied with x multiplied with y. Each of these factors cannot be further reduced. So, an expression when expressed as a product of its irreducible form is said to be in the factorized form. Another important thing was that these irreducible factors can either be a number, it can either be an algebraic variable, or it can also be an algebraic expression. For example, over here, 5 is a number, x is an algebraic variable, and we can also have an algebraic expression in case of irreducible factors. The next thing I taught you was the first method of factorizing any given algebraic expression, and the name of that method was the method of common factor. So what we do is, first of all, this method is applicable for those algebraic expressions in which we have a common factor from each of the given terms. Let's say we have 3 terms, and from all the 3 terms we get a common factor. So in this case, what we do is, the very first step is to represent each of the term as a product of its irreducible factor. And then what we have to do? We have to look and observe the common factor in each of the terms of the given algebraic expression. Next up, we have to take out this common factor outside the bracket, and then within the bracket, we have to write the remaining terms from each of the terms of the given expression. So, this has to be done in accordance with the distributive law. Let me explain. For example, if I have AB plus of AC. So, these are the 2 terms of an expression. Now, we know that this A and A are the common factor from both the terms. So, according to the common factor method, I took this A outside the bracket, and within the bracket, I will be writing the leftover factors of each of the term. Over here, the leftover factor is B, so I wrote B, and over here, it's plus of C, so I wrote plus of C. So, this has to be done in accordance with the distributive law. Okay? Now, sometimes we face a problem. Sometimes we get some sort of algebraic expression where we cannot find a common factor from each of the term of that expression. So in this case, we have to learn a new method of factorization, that is factorization by regrouping the term. Now, what we do in this method is, we try to regroup the terms. Let's say we have 4 terms. I regroup the first 2 terms and the last 2 terms. But this regrouping needs to be done with precision. I'll explain it to you. What we have to do is, we have to regroup the terms in such a way that from the regrouped terms, we get some common factor. If I am regrouping the first and the second term, I have to get a common factor from these 2 terms. So, I'll be taking out the common factor and I'll be left with the remaining factor within the bracket. And in doing so, what will happen is that from both the terms, we'll be getting common factor, and thus we can factorize our expression with ease further by using the common factor method. So, we can conclude from over here that in regrouping method also, the first thing we do is regroup the terms, and then we take out the common factor from those terms and then factorize our problem using the same common factor method. Another very important thing that you need to remember while using this second method of factorization, that is factorization by regrouping the term, is that it is not that if you regroup any term with any term, then you will end up factorizing. No, it is not the case. you have to group the right terms together. That means the regrouping has to be done in a trial and error method. By trial and error method, I mean that you have to try and see that which are the two terms or three terms that you are regrouping together is giving you common factor. You have to regroup those terms that has some or the other common factors between them that can be taken outside, and then the factorization can be proceeded in that way. So this is a very important thing. It is not that you take any of the first two and last two terms and then group it and factorize it. It will not give you the appropriate answer and your factorization will stop in between. You have to look for the appropriate regrouping method, and this can be done by the trial and error method. The next process of factorization that we learned was factorization using some of the well-known identities. Now, when to use it? Sometimes, like many a times, we get expressions that are of the form a square plus twice ab plus b square. Sometimes we even get expressions that are of the form a square minus 2ab plus b square. And sometimes we even get expressions of the form a square minus b square. Other times we might even get x square plus a plus b of x plus of ab. So it is not that you'll get exactly these same expressions, but expressions that can be represented in these forms. So in such cases, factorization can be done using some of the well-known identities. I taught you basically 4 identities, and these are very important identities. Learn them by heart because you will be needing it in a lot of places to solve a lot of problems. So the very first identity that I taught you was, repeat after me, a plus b whole square gives us a square plus twice ab plus of b square. The second identity that I taught you was a minus b whole square gives us a square minus 2 times ab plus of b square. The third identity that I taught you was a square minus of b square gives us a plus b whole multiplied with a minus b. And the fourth identity that I taught you was x plus a when whole multiplies with x plus b gives us x square plus of a plus b multiplied with x plus of a multiplied with b. Now, when we use the fourth identity, there are 2 important points that we need to keep in our mind. I have given you a question. This is x square plus 5x plus 6, which can be represented, factorized using this fourth identity. Now, x square plus 5x plus 6 can be written as x square plus of 2x plus of 3x plus of 2 multiplied with 3. So, ultimately, this gives us x square plus of x taken out common outside. We are left with 2 plus 3 plus of 2 multiplied with 3. So, from here the conclusion that we draw is that this numerical part is nothing but the product of a and b, isn't it? If I am taking this 2 as a and this 3 as b, the product of this a multiplied with b has to do with the numerical part of the question. That means whenever we are given a question like this, we have to look at the numerical part, that is 6, and this 6 is actually the product of the variable a and b. The numerical part deals with the product of the variable a and b. Now coming to this part, this coefficient of x. Coefficient of x means the term preceding x. This coefficient of x should be the sum of these variable a plus b. So, from here we can conclude that a and b should be chosen in such a way that their product gives us the numerical part, that is 6. And when we add up a and b along with the sign, we have taken plus 2 as a and plus 3 as b. Now, let's add up a and b with the signs. That means plus 2 and plus 3. It gives us plus 5. So from here we can conclude that when we add up a and b along with the sign, we get the coefficient of this x. And when we multiply a and b with the signs, we get this numerical part. So this was a very important thing in the fourth identity. The next thing that I taught you was division of algebraic expressions. Now, we know this thing that just like addition is opposite of subtraction, division is also opposite of multiplication. So this case is same for algebraic expressions as well. Like if we are multiplying two algebraic expressions, that means it is the opposite of dividing, or if we are dividing, that means it is the opposite of multiplication. And using this concept, we learned the division of different types of algebraic expressions. The very first thing we learned in division of algebraic expression was division of a monomial by a monomial. So that was done. And the next thing that we learned was division of a polynomial by a monomial. There were two ways that I taught. The first way was convert this polynomial and monomial division into a monomial division. How can we do it? We'll take each of the terms of the numerator and then divide it with the denominator separately. So in that way, we can convert our polynomial division as a sum of monomial division. And the second thing that I taught you was we can use the method of common factor in order to solve the division of polynomial with a monomial. We can take common factors outside and then that get cancelled out with the common factors of the divisor, and thus we'll be left with the quotient. The next thing I taught you was the division of polynomial with a polynomial. Now in case of polynomial division, you cannot use that method in which we were separating the numerator and the denominator. That means converting it into a monomial division will not work in this case. So what we have to do in this case? We have to use the method of long division when we are solving the division of a polynomial with a polynomial. In this chapter, we even observed while practicing problems of division of algebraic expression that we were getting the product of divisor and quotient as the dividend. But in general terminology, dividend is equal to divisor into quotient plus remainder. So we can say that in this chapter, we only considered those expressions in which the remainder was 0. Now, students make a lot of mistakes while solving these algebra problems. So such errors needs to be avoided. The most common error that I have seen is whenever you are doing a long division, what they do is they first multiply the first term of the divisor with a given term so that the multiplication gives the first term of the quotient, first term of the dividend. But then what they do, they forget to multiply this term of the quotient with the second term of the divisor. So this is a common mistake that I have seen in most of the students. So try avoiding such problems and mistakes. So thank you so much for joining me on Study Room. Hope to meet you in the next video.